A couple notes about balancing chemical equations. I'm going to go over some examples in a further video, but some notes. Our coefficients must be whole numbers. No decimals or fractions can be in a final balanced equation. There's a trick about having some decimals in there, but our final chemical reaction, our chemical equation, cannot have any decimals or fractions. The coefficients must be whole numbers. We can work with polyatomic ions in chemical equations. They've also got to be, they have to be balanced as a unit. So remember, polyatomic ions are ions that are groups of atoms. So those polyatomic ions, they move in chemical reactions as that group of atoms. So we don't need to split them up. We can treat that polyatomic ion like we would a single element. And I have an example of that in a video, and it goes over that, and it makes it much easier. And finally, and the most important one, is you never change the subscript to balance out an equation. You never change the chemical formula to balance an equation, because that changes the entire reaction. We know that hydrogen gas and oxygen gas form water, but we can't change that water into dihydrogen dioxide to make it work for us. It's got to remain water, and it's got to remain hydrogen gas and oxygen gas. We are not allowed to change the subscripts because that changes the compounds that we're working with. We can change the amounts of them, but we cannot change the actual compound we're working with. So by adding coefficients, we change our amounts, but we cannot change the actual molecule we're working with. So the next steps. Watch the 2 example videos I'm going to post on Google Classroom. Then you're going to go on to the PhET Balancing Chemical Equation site. We've used PhET before for our molecular shapes, and it's got a really good tool for balancing chemical equations. It's really easy to keep track. They've got a great tool to keep track of how many atoms you've got on each side. I want you to complete the introduction activity, and the answers that you get on the introduction activity are going to be questions on the quiz. So keep track. You can have it on the same screen or have the window open at the same time. But I'm going to need you to complete the introduction activity, and then you're going to take the follow-up quiz. Parts of that follow-up quiz are going to be the answers for that intro activity. And I'll try to go to a new screen right now and show you guys what that looks like. So if you follow the link on Google Classroom, you're going to get to this page. There's going to be an introduction activity. And basically, if you go to the tools and you make sure you've got the bars set up, you can balance this equation. You can balance the equation we just did with nitrogen, hydrogen, and ammonia. But what it does is as you add coefficients, it shows you're adding the atoms. It shows you how many you've got. It keeps track for you so we don't have to. So if we go to what the answer was that we've already gone through, we can see that it takes 1 molecule of nitrogen gas and 3 molecules of hydrogen gas to get us 2 molecules of ammonia. And you see at the top, it keeps track of each element for you. And then you can do the same thing for water and methane, which is what we're going to, what the quiz is going to be about. So you're going to go there, you're going to do it for water and methane. If you'd like to, I really encourage you guys to go onto the game part about it, and go in here, because it does the same thing as well right here that you can work on. But I'm not going to make that part of the quiz. Part of the quiz, though, is going to be the correct coefficients for water and methane. And then, so those are going to be in the quiz. You're going to submit the quiz the same way, and you'll get credit for participation.